Hey guys, hope everybody's doing well. We're going to take a look at number 6 here today from 2018. This is a good question because the College Board really likes asking differential equation questions, just because it incorporates so many different techniques. This question has you doing a lot of different stuff. So the first part is pretty easy. You have a slope field, given this weird differential equation. You have this slope field, and all you got to do is sketch two possible solutions to the differential equation, one that goes through point 0, 2, and one that goes through the point 1, 0. And that's as simple as just following the dots. Connect the dots and kind of follow the dashes to see where you should go next, which dot you should go to next. So if I'm looking at the point 0, 2, it's just a horizontal line, so it's pointing me in both directions to other horizontal lines, and so that possible solution would just be, it would look like just a horizontal line. It's at y equals 2. If we go through the point 1, 0, then this line was pointing me up toward this line, that dash pointed me toward this dash pointed me toward this dash toward this dash, and so on. And if I go the other way, and it's going to point me toward this point here that flattens out and then starts pointing me back up toward these other dashes that look like they're starting to level out. So that's it. That's all. That's the whole trick. You just connect the dots, and each one of the dashes sort of points you toward another dash to follow. So if you have both of those sketches, you're in good shape. Give yourself 2 points, one for each. Just make sure that both of them extend to the edges of the slope field. Don't stop short for any reason. I know I've seen in years past students just do like this half for some reason, and they didn't bother following the slope field over to the left. I don't know why, but make sure if you have a question like this, you definitely follow the slope field and connect the dots in both directions, okay? Make sure you go out to the edges of the slope field. Okay, so now for part B, we have this initial condition that f of 1 equals 0, and we want to write an equation for the line tangent to f at x equals 1, and then use that to just ballpark f of 0.7. So if you want to write the equation of any line, you need two things, a point and the slope. Obviously, the slope is going to come from the derivative right here, right? I hope that's obvious. You're going to plug in 1 to, well, I guess the point 1, 0, because this derivative involves x and y. So plug 1 in for x, 0 in for y, and you'll get the slope at your point. As far as the point goes, that is the point right there. The point is 1, 0. So let me just jump right into my work here. So the point was just given to us. F of 1 equals 0, so the point is 1, 0. And the slope is going to come straight from dy dx, plug 1 in for x, 0 in for y, and you get a slope of 4/3. So plug that into point slope form. Y minus 0 equals 4/3, x minus 1. Clean it up a little bit. There's really no reason to distribute the 4/3. So you're going to get 1 point if you have the equation of the tangent line. Any form of it. Even if you do distribute the 4/3, that's fine. I guess if you put it in standard form, you could multiply through everything by 3 and then distribute the 4. Who really cares? As long as you have an equation of a line that is equivalent to this one, then give yourself a point. We usually just keep it here because if we're going to plug a number in, this is the easiest of all the forms to calculate. If I plug in 0.7, then I can just do 0.7 minus 1 and get negative 3/10, and then clean it up from there. But I digress. Let me move back a little bit. So this is the equation of your tangent line. You want to approximate a value for f of 0.7. Now, f of 0.7 is not exactly y of 0.7, but close enough for government work. So that's what the squigglies is. f of 0.7 is approximately y of 0.7, which is equal to 4/3 times 0.7 minus 1, which is negative 2/5 or negative 0.4. Either one, obviously fine. So 2 points for part B here. 1 point for anything equivalent to this line, and 1 point for a correct answer of negative 2/5. Okay. Part C. Part C is the real meat and potatoes of this question, solving the differential equation. There's 5 points available here, and in the event that you get a question like this on the AP test, there's typically 5 points awarded for solving a differential equation. The first point is always going to be for separation of variables. So make sure you start with this differential equation and just separate your variables. Multiply the dx over to the other side. You're going to divide the y minus 2 squared over to the left, and there you have it. You're done. You can do whatever you want with the 1/3, but there's no reason to move it to the left because you're going to have to solve for y anyway. That is what this means. Find a particular solution y equals f of x. That means at the end they want the form of your solution to be y equals everything in terms of x. Does that make sense? So don't stop early. Don't solve for anything other than exactly y equals stuff. So here are all my steps. First thing is first, separate your variables. I already explained that, right? Move this stuff over to the left, move the dx over to the right. There's 1 point. You're going to get 2 more points for finding your antiderivatives. This is also pretty standard. After you separate your variables, you're going to get points for most likely both of the antiderivatives, one for each side. So on the right-hand side, I have 1/6 x squared. That's easy enough. On the left-hand side, however you do it, you should get to negative 1 over y minus 2, or negative y minus 2 to the negative first, doesn't matter. Anything equivalent to that is cool. Now, technically, I was using u substitution to get myself from here to here. If you skipped that, you either realized you didn't need to formalize it or you just kind of got lucky. But technically, that's the technique we're using here, is u substitution. So it can't hurt to be explicit about what technique you're using. I made u y minus 2, so du is dy, no fudge and fix necessary. Just call this u to the negative second. It integrates quite easily, and then go back to turn u back into y minus 2. So those are your 2 antiderivatives. 1 point for each one of those. If you forgot a plus c, then you're done. It doesn't matter what else you did from this point forward. If you have no constant of integration, then you're done. You're maxed out at 3 points. If you do have the plus c and you used it to find, or you used the initial condition to find a value for plus c, give yourself another point. So give yourself another point if you have a constant of integration. We only ever put it on the right-hand side with the x's, so that's where you should have yours. And like I said, you should also, I waited until I got all the way down here and cleaned this up. I solved for y first, and then I plugged 1 in for x and 0 in for y. And then you see I solved for c. You could do this at any point. You could have found c way back here. It does not matter. Give yourself a point if you have a constant of integration and you use the initial condition 1, 0 to find out a value for c. Whether you did it right away or you waited until later on to do it, doesn't matter. And give yourself a 5th and final point if you cleaned up your solution all the way down to y equals this. If you're following my work, so at this point, in order to solve for y, I'm going to have to flip both sides. Or you could think of it as cross-multiplying, or however you want to think about it. It doesn't really matter. I just think of it as flipping both sides. And I moved the negative over to the other side. So that's how I'm getting from here to here. Flip this, and we just get y minus 2. And move the negative over. So now I'm going to have a negative 1 over all this stuff. And I realize that's going to make an improper fraction, but I'm going to handle that in the next step. I'm going to add this 2 to the other side, and I'm also going to clean up this improper fraction. Multiply the top and the bottom of this whole thing by 6. So that's how the top became 6, and the bottom just became x squared plus c. There's no reason to have a 6 times c, because 6 times c is just some other c, so you can just keep calling it c. And then you'll see at this point, this is when I plugged 1 in for x, 0 in for y, and slowly, carefully solve for c. And then I plugged that c value back where my c value belongs, and I'm good. I think that's that. So 5 points for this whole question. Separate your variables, get both antiderivatives, don't forget your constant of integration, and find a value for it using your initial value, or initial condition, and then solve for y. Cool? If you did all that, give yourself 5 points. And go ahead, do me a favor, as always, go on Google Classroom and just leave a comment on your assignment so I know how everybody's tracking, okay? If you have any questions, don't hesitate, reach out, and you guys have a nice day, all right? Take it easy.